Greetings and welcome, friends. Mr. Waddy here. We're taking a look at postulates and diagrams, page 87? From the homework. That's an affirmative. 87. Probably some problems from 88. Ocho, right? That'd be so great. So here we go. It says, use the diagram to write an example of the postulate. See example 2. Hey, wow, good pro tip. Hints right there. The line point postulate. Postulate 2.2. Okay, let's see. I'm going to reference that because I might not remember what that is. So the line point postulate claims that a line contains at least 2 points. All right, so for the line point postulate, I would maybe say that points J and K, maybe, I think those are good ones, are on line Q. You also could say that line Q contains points J and K. Something to that effect. All right, how about, and then here's question 6. We did do question 6, I believe, yes. Line intersection postulate, I believe it says that two lines intersect at a single point. So I think but let's verify that. It says if two lines intersect, then their intersection is exactly 1 point. Good times. So I'm going to say that point H is the intersection of lines Q and P. Right? And that's lowercase p. I guess there wasn't an uppercase, so we're fine. All right, so it's just kind of like referencing the postulates, being aware of what they say, and then applying them. Let's see. Here's questions 15 and 19. Did we do? Yeah, we did do odds for this batch. Yeah. So I almost wanted to do an even. I was so tempted, guys, but I was like, all right. So let's see. Use the diagram to determine whether you can assume the statement. All right. So points Q, J, and M. Q. All right, right there. J and M are collinear. That's a good one, friends. Wow. I'm going to say no. No way, Jose. Because Q and J exist on plane W, while J and M exist on plane X. Those are absolutely not collinear, right? We almost have like the right perspective we're looking at it, where they almost line up, but those are not collinear. Those 3 points, there is a plane that those pass through, but the fact that these planes intersect at some angle, right, other than a 0-degree angle, they are not collinear, but they are coplanar. Because we did talk about, right, that any 3 points are coplanar. Any 3 non-collinear points, where's that one? Let's see, through any 3 non-collinear points, there exists exactly one plane. Bam. Good stuff. But yeah, these points are not. Let's see, I don't feel like writing it down. I said enough. I think my words, just turn on the subtitles, the captions, and yeah, this YouTube video might be good. Google subtitles, by the way, are getting better, I've noticed. Also, it's terribly amusing to watch sometimes my videos with captions and just, I was actually going to make a Twitter account just called Waddy Math Captions, and then just like tweet out the most ridiculous things that YouTube thinks I was saying, and just like see which tweets, you know, would get the most, I don't know, retweets, I guess. Sure. Let's see, question 19. Angle nickel and angle JKM are vertical angles. So let's see, I'll swap colors here just for the sake of using the same diagram. Let's see, NKL, okay, and JKM. Guys, I think that's true. That's TRUE, or yes. I can assume. True, I can assume this. Yeah, because they form 2 pairs of opposite rays, being ray Kn and Km, and ray KJ and ray KL. All right, so true, true, true. Let's see, how about these ones? Critical thinking. Oh dear, my goodness. Whoop, flickering here. I was gonna pull up a diagram from the book because I thought it was pretty good. But maybe I'll draw it. Actually, yeah, I super can draw that. It says, if two lines intersect, then they intersect at exactly one point by the line intersection postulate, also known as LIP. Actually, not. No one calls it that. Stop calling it that, guys. Do the two lines have to be in the same plane? Draw a picture to support your answer. I'm going to say yes. Because they intersect. Okay? So I'll draw my answer first. This was my picture here. Minute. Oh man, super not realistic. Actually, this drawing tool has some pretty cool perspective drawing tools that I can like implement. I was pretty impressed. Let's see. So let's say that this is one of the lines. Okay? And we know it intersects the other line. So let's say this is the other line. Now the green line existed, maybe I was thinking about it existing in this plane, and the red line we were maybe thinking about it existing in this plane. But the fact that they intersect, there must be a common plane that those share. Okay? Like no matter what, because they intersected. The justification is this. Okay, so those two lines, they intersect at a point. There must be, on this line, let's see, let's pick the lighter blue, another point, okay, that exists because on any line there are at least 2 points, okay? And on this red line there must be another point, so there's that one, okay? What's the name of the postulate that allows that to be true? Is that the 2-point postulate? Through any 2 points there exists exactly one line. And then, sorry, more specifically, 2.2, a line contains at least 2 points. So I've just given specification of that being the case. And now notice this. I have now 3 points. And those 3 points, through them not being collinear points, there must be exactly one plane that they pass through. Thought, question, comment. Through like this. To this one. Okay, if that was my line, there is an invisible plane which would be like the vertical slice of this box, okay? So it's not drawn, and it would be hard to see because I'm looking at it like straight on. But yeah, so that would exist. Actually, yeah, imagine this, or like here's a random point. If, say, this line intersected, then even the purple and that, there would be a common plane that is like a weird side swipe of the box that would exist that passes through those. Well, let's see. So anyways, back to the blue points. Since I have 3 points that form a plane, the lines that pass through those points exist entirely in that plane, and then those 2 lines are on the same plane. All right, that's the idea. Actually, maybe I will show you the picture that the book gave. Whoa, making an argument. Oh, man. Breaking the fourth wall again, Mr. Waddy. You don't want to save it for the bonus content, for the bloopers reel when, I release that at the end of my YouTube playlist for geometry. And you guys want to see, like, the making of video? Mm-hmm. Okay. Oh, like you were viewing them as being coincident lines, the same line. Right, yeah. Yeah, so that wouldn't have made as much sense. So here they had 2 lines, and then they did the same argument. So here's their intersection. Another point must exist on that line, because any line has at least 2. Another point exists on that one, because any line has at least 2. And then any 3 points, there's a plane that contains them. And then those lines must exist entirely in those planes. All right, let's see. 31. Your friend claims that even though two planes intersect in a line, it is possible for three planes to intersect at a point. Yeah, definitely. Sure. Yes, he's right. I'm going to say yes. Man, that's the weirdest why. Okay, here we go. Look at plane 1, right? Plane 2, and plane 3. And we'll color down there too. And they have a common point, which is the corner of the box, right? Definitely true. And then notice that yellow and orange have this as their common line intersection. Red and orange have this as their common line intersection. And actually, even just think about that. If these two planes have a line intersection, and those two planes have a line intersection, that two lines intersect at a point. So you can kind of even like follow the logic that far. Question, is it possible for three planes to intersect at one line? All right, let's see if I can draw this picture here. All right, here we go. There's one plane. All right, so imagine this is their common intersection right there. There's two planes. And let's get another one in here. Oh, ooh, whoa. And three planes. There are actually infinitely many planes that I could have that intersect in a common line. Man, I almost want to look at this with like 3D glasses just to see. I wonder if I could draw. Maybe someday I'll try. Anyways, thanks for watching, internet friends. And remember, your friends aren't always right, but sometimes they are. And when they are, they justify it with postulates. So have a great day.